Hi everyone, my name's Archie Robson. I'm the Deputy Director for the Hemley Project. So today I wanted to talk to you all about GIS and how you might want to use it for your own projects. So what is a GIS? It stands for Geographic Information System. And what essentially it does is to connect data to maps, integrating location data with descriptive information. So that would be names, numerical values, etc. Most GIS data will combine geometry, so that can be shape and location, with attributes, so that could be type, size, or color, displayed through map symbols. And GIS stores data usually as a 2D raster or a vector file, and we'll come on to those in a minute. So there are plenty of applications of GIS software, and I've only just covered the ones that are relevant to archaeology and to environmental science, and there are 1,000 different applications. So it's used a lot in conservation, for instance, to track wildlife. If you've got wildlife cameras or chips in different wildlife populations, or to map changes in biodiversity or in habitat loss. It's used increasingly in archaeological project management for things like site overviews, desk-based assessments, but also in large-scale excavations. And on a research basis, it's used for inter-site analysis, that's between individual sites. So look at things like density, the topography, the relationship to the topography of the landscape, relationship to natural or man-made features, such as rivers, or least cost analysis, so the distance it takes to get usually walking distance from one site to another. But also for intra-site analysis, so this is within individual sites. So that could cover, for a prehistoric site, you might be looking at lithic scatters, structure layouts, and relative chronologies of different structures. And so this is an example from Kunle Cave in Czechia, which is a Middle Paleolithic site. So I've used GIS to make this wonderful map, highlighting different excavation areas, and also and you can see in this legend, so the different density of certain tool types and the distribution as well. So it's layering both the several different attributes. And also it shows the topography, the layout of the cave system in the cross-section sense. So there are some key features to QGIS. This is only just the very basic that you can build on, So it's a free and open access software, importantly. So it doesn't require a university license to download it. It's essentially what it does is visualize spatial data in different map projections, no matter the format. So, which also the other common alternative is ArcGIS, but this I prefer them purely because it's more user friendly, and you can add plugins in a more accessible way. With QGIS, you can bookmark, label, and publish maps. You can digitize vector and georeference rasters. You can analyze spatial data with integrated tools and plugins. And you can add functions with Python plugins, as I alluded to earlier. You can also, if you know your code, you can write new Python or C++ plugins within its in-house console. So this is 4 maps of High House Farm in Hemley, so that's where we're working, but overlaying on maps of different time periods. That's today's satellite map. That's the OpenStreetMap, which is based on satellite data. You've got the historic OS map from the mid-20th century, and then you've got a tide map from the mid-19th century. So as you see, there is a slight inaccuracy just because of the changes in field boundaries and changes in the landscape. But broadly, you can see how the farm has evolved through time. So this is a step-by-step guide on how to use QGIS, or at least how to get started with QGIS. I would consult the forums and for more detailed guidance. So to create a document, go to Projects. That's in the top toolbar. Go to New, Project New, or Project New from Template. So that's if you want a particular template. And you can use Control N for a shorthand as well. So 2 things you want to remember are WMS and CRS. So WMS stands for Web Mapping System. So this is a virtual map. So this will be the default on QGIS is the OpenStreetMap. And other maps include Esri World Hillshade, Google Satellites, which are also available through the QMS or the Quick Mapping Services panel on the top toolbar. And all WMS can be set to a specific coordinate reference system or CRS, which changes the projection of the map. So the standard for the UK, which is the most true to life, true to scale, is OSGB 36. And there are different accuracies as well, depending on the kind of scale you're dealing with. So I tend to go for the most accurate, but that can be a bit slower. So it really depends on the scale. So if you're doing something that's on a regional level, that's not so important. If it's on a smaller scale, the accuracy is more important. As you can see, there are a wide variety of CRSs for pretty much every part of the globe. So moving on to rasters and vectors. So vectors are points which can store X, Y, and Z values. So these can join into these are individual points. They can join into polylines, which are made up of string of points, also known as vertices, and polygons made up of an enclosed line of vertices. And importantly, these can adjust with the map scale, but at smaller scales, these can, depending on how detailed you want to make them, they can look quite angular. While rasters are image files, where each pixel stores a value representing the conditions of a location covered by that pixel. As these are fixed size, these scale up poorly compared to vectors. So this is the same tide map with vector shapefiles of different crop marks superimposed onto it. So this is the possible Roman enclosure that we have, or set of enclosures that we have. These are the curvilinear anomalies, which we tried to investigate with our field walking a couple of months ago. And there are some other rectangular and linear anomalies which cropped up in recent drone and satellite imagery. So as you can see, this is from 1845, but it shows the relation between the two. So another important thing is the CSV files, which stands for comma separated value. So these are text files with defined geometry, so usually a latitude and longitude or an X and Y. So these typically consist of just really an Excel table with rows of names or numbers and XY values. So to give you an example, this is a CSV file made of the hut circles or suspected barrows in the areas. Anything that looks like a ring-shaped anomaly, which may be a prehistoric barrow or hut circle, I've compiled into the CSV. So this is its sort of historic environment record number, the X and Y, and then the description and also a type, so you can kind of classify them and color them accordingly. So another important feature of QGIS is georeferencing. To do this, you go to Layer on the top toolbar, and there's a georeferencer option, and it comes up with this pop-up. And so in order to georeference, you need to have ground control points, which link to a raster map or image to real-world WMS data. So generally, the more GCPs you can put down, the better. But sometimes it can be misleading. If you put them all in one area, it tends to warp projection too much to one side. And it's obviously dependent on the accuracy of the source map and the presence of common features. So things that generally would have stayed the same between the modern day satellite imagery and the image you're hoping to georeference. So things like buildings, sometimes road junctions, but definitely not trees or hedgerows, which can change, month on month. And it's usually a trial and error process. The larger and more detailed the source map, the larger the area that it covers, the better it is usually. So this is a map of OS map of Hemley, which I've tried to georeference, but it's slightly out, but it's particularly because the salt marsh has fluctuated over the years, but it's more or less where things should be. So another useful thing to know to get started is how to create a shapefile. So to create a shapefile, you go on the Manage Layers toolbar on the left-hand side, and you create new shapefile layer. And so there are different geometry types you can choose from. Just a point. A multi-point is 2 points. A line string or polyline is 3 or more points. and a polygon is an enclosed line of points, an enclosed polygon. And you can create fields, add attributes to the shapefiles, for instance, the top, what it is, what kind of what type of feature it is. And so it looks like this shapefile. So I haven't really bothered with the fields list, but you can see I've selected polygon and made sure the CRS is the same as the project CRS. Otherwise, the protection will, the shapefile might end up in the Isles of Scilly or in Equatorial Guinea. So you've got to be careful. So to edit a shapefile, so if something doesn't look quite right, which can happen accidentally if you misclick or you just click a bit too far. So go to digitizing toolbar and toggle editing, which is the pencil icon, and that opens up the advanced digitizing toolbar, which you can draw, move, reshape, rescale, and polygons and polylines. And there's also the vertex tool, in which you can move individual points. So for instance, this is a kind of claw-shaped polygon I've created in QGIS, and if I wanted to edit it, I can just edit any one of these vertexes to move it out. Other vector tools include, if you go to the processing toolbox, and so this is all on the right-hand side. This is useful if you want to create new vectors, extract new vectors based on existing data, existing vector data. So you go to the processing toolbox, and there's the option vector analysis, creation or selection. So selection, you can go to extract by attributes, which creates a new file only with points, lines, or polygons with a particular attribute, e.g. prehistoric. Selection, you can extract within distance. That's quite useful if you want to know about the features in the given area. And vector creation, which you can convert pixels to points, which is quite useful for scaling up a building, although you've got to be careful about the quality of the source raster when you do that. So a quick note about symbology as well. So if you go to layer properties, and so that's back on the left-hand side, go to symbology, so you can change the color, opacity, size, rotation, shape, and rule set symbols. And so you can change the symbol itself, the rule set from categorized to gradiated, or to heat map. And the heat map is quite useful if you've got lots of features, but you want to look at the density or in different areas. But it's not useful for fine-grained knots. It's better on a scale of, say, tens or hundreds of kilometers. And yeah, categorize is quite useful as well. So that's what it looks like. You can change that single symbol to categorize, gradiated, or heat map, and you can change the symbol to pretty much anything you want. I believe you can import symbols as well, so you're not restricted just to the set symbols it gives you. And hill shades, which is probably the most interesting part of QGIS, because you can do a lot of fancy things with hill shades. So this is a hill shade I created, or comps hill shade of the Clwyd Valley in Denbighshire, so northeast Wales. So this is you apply these to WMS files. If you go to layer properties, symbology, and band rendering hill shade, and so the variables include altitude, so that's the direction of the shadows, azimuth, which is basically just where the sun sits in the sky, and the Z factor, which is the strength of shadows and relief. There's a few things you can change about the gamma and the contrast if you want to make the hillshade pop as well. But yeah, that's good in itself. But there are plugins which can enhance the existing hillshade. But the one I recommend is Map Tiler, which you do have to pay for, but there is a free trial, and that's quite useful. Especially if you want to look at areas of quite they're not particularly hilly, they're quite flat, but there are some archaeological details you want to enhance, or earthworks you want to enhance. That's quite useful. So, and again, there are lots of tutorials online about Map Tiler. You want to follow down that route. So just something about rivers and other data sets. So there are quite a few plugins. The ones I recommend are the Copernicus e-River Network, OS Open Rivers, and the UK CH Watercourse Map. The last one does include man-made watercourses, that's canals, culverts, irrigation channels. And there are also other data sets you can combine there are millions of plugins available online. One could be the Glad Forest Loss map, which is kind of ironic in a way because it's a very sad thing, losing forests. But you can see, for instance, looking back at the Upper Clwyd Valley, see the rate of forest loss. That's the red is sort of severe forest loss. The yellow is moderate. A very useful layer to add is the BGS geology viewer, which includes the surface geology. That's just what's underneath the soil. So that's just things like glacial till, sort of Pleistocene sand deposits, any surface outcrops. But bedrock geology is basically what's underneath everything else. That's sort of things like the Carboniferous coals, Permian mudstones, things that have been sort of sat there for hundreds of millions of years rather than just thousands. Just quick final note about GPS data. So QGIS is very useful, as well as other GIS systems, for matching up with GPS data. So if you go to Data Source Manager toolbar, which is on the top row, and Data Source Manager, and GPS, and so you can import GPX files, or you can go to Projects, Import/Exports, import layers from a drawing or DXF for DXF files. So that's what DXF is going on most GPS software for use in CAD. It's used for things like site setouts, so it's like trenches that are going to be excavated, and for overall site plans. And then GPX files they can be used for both, but that a common use for them is in photogrammetry targets, which are small paper crosses placed on the surface in order to create essentially man-made ground control points for resulting models. So they help knit together photogrammetric models, particularly orthomosaics. So you can have a nice top-down plan of, say, a building or a roundhouse or an archaeological surface without having to with much greater accuracy than if you're just using one flat photo. That's a good example. So this is a large strip map record that's sort of midway through excavation, but they managed to tie everything together with these photogrammetry targets. So yeah, that's the end of the talk. It's really just a brief kind of sort of toe in the water in terms of QGIS and GIS software. So if you've got any questions, just let us know at on the Instagram or the LinkedIn, or you can contact me at Archie Robson's work@gmail.com. Okay.